Hi, I'm Swarupa Sail, course instructor for Geotechnical Engineering 1. In this presentation, we will learn about field compaction control. For proper control of compaction in field, it is necessary to frequently check the dry density and water content of the compacted soil in the field. After compacting the soil by roller, we need to find out what is the dry density and water content of the compacted soil. The in situ density, that is dry density in field, is determined by the following methods. First one is sand replacement method and second one is core cutter method. Water content is determined by oven drying method, sand bath method, calcium carbide method and Proctor needle method. Sand replacement method is conducted as per IS 2720 part 28 and it is suitable for both coarse and fine grained soil. Apparatus consists of sand pouring cylinder. Bottom is of cone shape with hole at the center which can be opened or closed with the help of knob. This is a calibrating cylinder whose diameter is 10 cm and height is 12.73 cm. This is a metal tray with hole at the center. Volume of the calibrating cylinder can be found using formula area into height. Area is pi by 4 d square and height is h. Diameter is 10 cm, height is 12.73 cm. So we get volume as 999.8, which can be written approximately equal to 1000 cm cube. Sand pouring cylinder is filled with clean free flow sand which passes through 1 mm ISU and is retained on 300 micron sieve, and it is filled by leaving a gap of 1 cm from top. Its total initial mass M1 is found and shall be maintained constant throughout the test for which the calibration is used. So M1 is equal to mass of the cylinder with sand which is there inside it before pouring. After this, sand pouring cylinder is placed on calibrating container. Shutter is opened and sand will be allowed to flow into this calibrating container. After sand stops to flow, the shutter is closed and the mass of the sand pouring cylinder along with the remaining sand is noted down. So M2 is equal to mass of pouring cylinder with sand after pouring into calibrating container. Sand is filled over the calibrating container in conical shape. If suppose this is the sand pouring cylinder which is placed on top of the calibrating container. After the shutter is opened, sand starts to flow into the calibrating container, and since bottom of the cylinder is in the form of cone, a conical heap is formed on top of the calibrating container. So mass of sand of the conical heap over the calibrating container has to be found. So to find this mass, we need to place the sand pouring cylinder on the glass plate, and then shutter is opened and sand is allowed to flow. The mass of the sand which is collected on the glass plate is noted down, which will be equal to M3. So this is M3. And this procedure is repeated 3 more times with same M1. Mass of sand to fill calibrating container is equal to MA, which can be found by using equation M1. M1 is the total mass of sand plus the sand pouring cylinder before pouring, and M2 is mass of sand in this calibrating container and also the mass of sand which was in the form of conical shape, and M3 is only the mass of this conical heap which was formed over the container. And mass of sand to fill this container will be MA equal to total mass of the sand before pouring the sand minus mass of sand after pouring into the calibrating container minus mass of this conical heap. And bulk density of sand rho S will be equal to MA divided by volume of this calibrating container. Next, we need to find dry density of the soil. A flat area approximately of 450 mm square of the soil to be tested is exposed and it is trimmed down to a level surface with the help of scraper tool. The metal tray which is having hole at the center is placed on the prepared surface of the soil with the hole over the portion of the soil to be tested. After that, soil is excavated up to 15 centimeter and the excavated soil is collected in this metal tray and its mass is noted down. So, mass of soil from hole is denoted as MW. After that, sand pouring cylinder of mass M1 is placed on the excavated hole and shutter is opened, due to which the hole is filled with the sand. The sand pouring cylinder is taken out and its mass is noted down, which will be equal to M2. The mass of sand of the conical heap over the excavated hole has to be found. To find conical shape sand mass, place the sand pouring cylinder on the glass plate and shutter has to be opened. Sand is allowed to run out of the sand pouring cylinder and shutter is closed. Now we need to note down the mass of sand which is collected on the glass plate and it is denoted as M3. Finally, mass of poured sand which is filled on the excavated soil hole is denoted as MB, which will be equal to M1 minus M2 minus M3. Volume of sand filled in the hole V is equal to MB divided by rho S. We know that density is mass by volume, so volume will be equal to mass divided by density. And bulk density of soil is equal to rho B, which will be equal to mass of soil which was excavated from the hole divided by volume V. After that, we need to take out some soil sample to determine its moisture content. So, dry density of soil rho d will be equal to bulk density rho b divided by 1 plus W, that is the moisture content which we determined for the soil sample. So this procedure is to be repeated for 2 different locations and average value of 3 determinations has to be noted down. Thank you.